Our last topic on the conic sections is about the hyperbola. In this lesson, we will be learning about its definition and the general form, the equation of a hyperbola in standard form, and the reduction of the general form to the standard form. The hyperbola is the conic section with eccentricity greater than 1. That is, the distance from your focus to point P over the distance of your directrix to point P is greater than 1. The directrices are the fixed line of distance d from the center. In our figure, these lines are the directrices, and its distance from the center of your hyperbola going to the directrix is equivalent to distance d. Foci. These are the fixed points of distance c from the center. In our figure, it is referred to as the f. The distance from your f to the center is given by the symbol c. The transverse axis, the distance from the vertex to vertex. The distance from the center to vertex is a. Thus, the distance between your vertex to vertex is 2a. Conjugate axis, the axis perpendicular to the transverse axis through the center. Half of the length of the conjugate axis has a length b, or in this figure, from the center going to the end of your conjugate axis is length b. Latus rectum, the segment passing through the focus and perpendicular to the transverse axis. Its total length is 2b squared over a. In our figure, these are your latera recta, with distance 2b squared over a. Asymptotes. These are the lines to which the parabola never touches. If we extend our parabola, its points will never intersect with this line, or the asymptotes. The eccentricity of the hyperbola is obtained by the following sets of equation. C over A is equal to E. A over D is equal to E. The following equations are true for a hyperbola. C squared is equal to A squared plus B squared. C is equal to AE. D is equal to A over E. And E is equal to square root of A squared plus B squared over A. Theorem. An equation of the second degree represents a conic section, and conversely, ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. The hyperbola is defined as the conic whose eccentricity is more than 1. It is generally represented by the equation ax squared plus cy squared plus dx plus ey plus f is equal to 0, where your a and c have different signs, and your b is equal to 0. Standard equation of a hyperbola. Hyperbola with center at the origin. Hyperbola with center at coordinates hk. The standard equation for hyperbola with center at the origin, with transverse axis parallel to the x-axis, that is x squared over a squared minus y squared over b squared is equal to 1. For a hyperbola with transverse axis parallel to OY, or your y-axis, that is y squared over a squared minus x squared over b squared. Standard equation for hyperbola with center at coordinates hk, with transverse axis parallel to the x-axis, x minus h squared over a squared minus y k squared over b squared is equal to 1. For hyperbola with transverse axis parallel to the y-axis, y minus k squared over a squared minus x minus h squared over b squared is equal to 1. As we can observe from the arrangement of our equation, your a, or the distance from the center to the vertex, is in the denominator of the term containing your x for transverse axis parallel to x-axis. If your hyperbola has its transverse axis parallel to the y-axis, the distance a, or the distance from the center to the vertex of your hyperbola, is in the denominator of your y-axis, or the term containing your y.